Hello everyone, my name is Zain from UPJB, France. The topic of my presentation is solar hybrid photovoltaic thermal systems for drying. The presentation is divided into following sections: introduction, drying, modeling, the proposed scheme, results and discussion, and presentation ends with conclusions and perspectives. Solar energy harvesting is becoming popular because of global warming, rising fuel prices. A PVT system combines photovoltaic module and solar thermal module into one integrated unit. The heat is produced by the thermal module, whereas electricity is generated simultaneously by the PV module. The circulation of fluid plays an important role in heat extraction, and this fluid can be air, water, or phase change material. The PVT systems produce heat and electricity with an efficiency of more than 50%. The heat extraction medium not only produce heat but also reduce the temperature of PV module, which results in an increase of PV efficiency. These systems have various potential applications such as drying, cooling, heating, etc. Drying is a fundamental process in many industrial applications using more or less advanced technologies. It is very popular in developing countries for preservation of agricultural products. The dried products are a good source of nutrients, but dehydration process may alter the quality of the product. The drying process is very important and must ensure that the dried product satisfies recommended specifications. Therefore, a lot of research has been done and is always ongoing. Controlling the drying process is very important in order to guarantee the quality of dried products in terms of color, flavor, retention of nutrients, etc. The schematic diagrams of PVT drying system and solar dryer are presented in Figure 2 and Figure 3. In this study, air is used as a circulation fluid, and the PVT collector consists of 5 components: glass, PV cell layer, tubular and air channel, and an insulator to reduce heat losses. Energy conservation principle is used to obtain the governing equations, and few assumptions are made, such as pressure losses, edge losses are neglected. The block diagram of the PVT dryer is presented in Figure 5. The main factors influencing drying are the mass flow rate, which is the main control action, drying temperature, and a high drying temperature may damage the product, solar radiation and ambient temperature, which are very important and cannot be controlled. Energy is mainly solar, but other sources may be added such as electric or geothermal energy. In the proposed scheme, the output of PVT, which is hot air, is used for the drying, whereas electricity generated by the collector can be stored and used when needed. The waste heat at the outlet can also be recovered and used to improve system efficiency. As shown in Figure 6, under recycling scenario, the outlet air is recycled from the output to the input of the PVT collector. It is assumed that inlet temperature of air is proportional to the output air temperature. If recycling efficiency is high and airflow rate is low, the output air temperature is close to its maximum. This means that it is only needed to set the airflow to a low value. The control is very useful for simulation analysis and also in process with relatively stable environment. However, it may be sensitive to parameter variation and external variables. The MATLAB program is used for the simulations. Two cases with different ambient temperature and solar radiation are considered to see the influence of the mass flow rate. Case 1 is presented in Figure 7, whereas Case 2 is presented in Figure 8. The results indicate that higher temperatures are obtained with lower mass flow rate values. In Case 2, we can see that the output air temperature goes to 45 degrees Celsius with lower mass flow rate, which is 0.005 kg per second, and the outlet air temperature is just above 35 degrees Celsius with higher mass flow rate, which is 0.025 kg per second. The PV cell temperature is the highest as compared to other components, which is tubular in the black color and insulator, which is in yellow color. Now let us consider a reference value for the outlet air temperature. For instance, 50 degrees Celsius, 55 degrees Celsius, 60 degrees Celsius with solar radiation of 800 watt per meter square and ambient temperature of 35 degrees Celsius to compute the air mass flow rate. The opening results show that to achieve 50 degrees Celsius, we need higher mass flow rate, which is 0.0029 kg per second. But to achieve higher temperature, which is 60 degrees Celsius, we need mass flow rate of 0.0009 kg per second. In recycling scenario, input temperature is proportional to the outlet air temperature, and air output temperature rises to 40.43 degrees Celsius from 39.68 degrees Celsius with solar radiation of 600 watt per meter square. Similarly, with solar radiation of 900 watt per meter square, the temperature rises from 42.04 degrees Celsius to 45.02 degrees Celsius. An interesting observation is that at lower solar radiation, the difference is small, whereas as the solar radiation increases, the difference gets larger. Here are our conclusions and perspectives. It is obvious that the PV cell temperature is higher than the other components. The lower mass flow values implies higher temperatures for all the components. The outlet temperature difference is small at lower solar radiation, whereas it gets bigger with an increase in solar radiation under the recycling scenario. The control is very useful for simulation analysis and in a process with relatively stable environment. Further developments can be considered, such as closed-loop control synthesis and experimental results on a concrete dryer with a quantity of product to dry. An economic analysis would be useful to evaluate the profitability of investment in such technology, considering the capacity of drying, which depends on the product. The authors would like to thank European Solar Ice Project for the support. Thank you for your time. I will now answer any questions you have about the presentation. And if you need any information, feel free to contact me.